Welcome to Made Up of Wires. We are going to be decompiling Castlevania Symphony of the Night today. If I can figure out what's gone wrong. With my environment. Hopefully we'll be decompiling Castlevania Symphony of the Night today. Let me, I see. I was doing some other work, and looks like I broke some things, but that's okay. We can always fix them. So, if you'd like to know more about Castlevania Symphony of the Night and the decompilation project, you can go to SOTN.z.dev, where you'll find a link to the GitHub repo, which has the source that we've been able to decompile. You'll also find a link to a Discord server, where you'll find us having various conversations about decompilation. What we found, there's some crossover between the Decomp Discord and the Long Library Discord, which talks about all kinds of other things related to SOTN. But we're here primarily to decompile. I think there's a few things that would be fun, and then I think we'll get back to some of the weapons. We've been working on weapons lately. There's two weapon objects that ship with the PlayStation version of the game. These are broken out into separate files for the PSP version of the game and some of the other versions as well. But on the PlayStation, there's just two of them, Weapon 0 and Weapon 1. And within each of those, there are 55 or so weapons defined. And I should say 55 divisions of weapons, and many of the game weapons can be assigned to any one of those divisions. And so we were working on, I believe, the Werebane yesterday, and we might get back to that. There's 8 weapons left to decompile in the Weapon 0 module. And so we're trying to get through and get that fully decompiled. And hopefully it will be portable after the data gets imported as well. Let me get my stream dashboard going so I can follow chat if there's any. Feel free to comment, ask questions, anything like that throughout the stream. I'm happy to answer anything. What I wanted to start with today was not getting right into decompilation, but actually looking at some of the changes that randomizer does when it's either building a disk or giving you a patch file for a disk. Some of those things are relatively straightforward. Some of them are a little more convoluted. And I might play through a bit and try to find some of these areas that have been changed, where we do have the code already decompiled. I was trying to get GDB working again before we started, but for whatever reason I can't seem to get GDB to attach properly to DuckStation. And maybe it's just that the integration there isn't very good. All right, so when you go to the SOTN randomizer, and I'll pull that up. At SOTN.io. Oops, of course. I'll struggle with tab management along the way. This will allow you to either generate a bin from a qbin pair that you provide, or it'll allow you to download a patch, which you can then apply either in an emulator or offline if you want. So then there's several options, different presets that will set different things, as well as options within those presets for you to tweak the game as has been tweakable up until this point. So I had generated a randomized SOTN a few weeks ago, and I was playing through and trying to look at where and how some of the randomization worked, because from what I can tell, looking through their repo, they're targeting specific addresses. It looks like on the disk, and tweaking those values, which then get loaded into memory. So they have to do a bunch of work actually to map disk locations to file offsets, which then are mapped to different addresses in memory. Our job on the decompilation project is actually a little easier because we have files that have been extracted and the offsets within those files compared to the offsets in memory are relatively straightforward mapping. The mapping didn't look as straightforward when I was looking at it. So I would like to go over to a terminal and just do a diff between some of the extracted assembly. There is definitely data that is different between the two, but I thought the assembly would be a little more interesting. So let me clean this up a little bit before I switch over, and I'm sharing the wrong terminal, so I'll fix that. There we go. So what I was doing earlier is just using diff to look at, I've all the assembly extracted into ASM Retail and another one into ASM Rando. So I'm going to look at the US version of the game. I started with, we could look at a stage, something like NO3, and we could look at, so non-matchings is where functions that have not been decompiled yet are. This is a forced extraction using splat, so we get the assembly for all functions regardless of whether they've been decompiled or not. And I have the same layout for a rando version of that ASM and the matchings. And so if I do that, we can see which of these functions are different between the two. So we see some background lighting differences, entity merman, entity stairway piece, entity room transition, and bone scimitar. So let's look at, I was looking at the merman earlier, so I kind of know where that one will go, but we can look at the other ones as well. So I'm going to do just a normal diff. And so here there's just one instruction differs between the retail release and the randomized release. And it's setting this value hex 43 or hex 1D, depending on which version you're looking at. So the 43 is from the retail release and the 1D is from the randomized version. So I want to I'm going to look over here, and we have this function decompiled already. So we can try to find what this value originally was and what it's being changed to in the randomizer. So I'm going to look for that in the NO3 code. And this was, we don't have these hard-coded hex values that show up in the assembly, They don't always translate directly. They could be converted to base 10. They could be converted to macros or enum values. We don't know specifically. So in this case, I knew that this was happening somewhere around the third call in this function to create entity from entity. And it basically was the line immediately after that. And so here we see item pot roast. And looking at that definition, that was in the wrong header. It's in the items header. I was wrong, not it being in the wrong header. So item pot roast is equivalent to hex value 43. And so in this case, we have it looks like a case where potentially the merman is dying and dropping a pot roast. But the randomizer is changing that to 1D. And so in our case, for our randomized version, we'd be getting an orange. So somebody had to go in and find this particular location in memory, map that. How that's done in the randomizer, I'm still not quite sure. I was trying to find some straightforward method of determining how they identify and store all these addresses and do the mapping of items, but I haven't cracked that code yet. They actually have pot roast as one of the examples of items that can be changed to something else. Their example is changing, in NO3, changing pot roast to library cards. But I don't see anything like the pot roast like as a constant keyword in their repository, so I still need to go through and figure out how they're doing what they're doing. Let's look for something maybe a little more involved. So in that case, they're changing a constant value, which doesn't require any code changes, but there are places where code is changed by the randomizer. And I'm not sure if there are any in NO3, but I know where some others are that we can look at as well. So I'm going to run this through less, so I get a pager. So in NO3 it looks like it's primarily just item changes, and we can kind of go through and see what each of these are, but I think the transition between pot roast and the orange is straightforward enough. There is this this constant up here and down here as well, and we can look at that to see what this might be related to. I have not looked at this one yet. So this is at offset 4027C. And we'll go to the retail release first and find where this is. So we're loading this A0 value. And then it's being passed to, it looks like, oh, not passed, potentially being used as an index for this primitive buffer. So we'll open this file and see what this might be. This is a longer function. And it looks like sound effects. So we can see if there are names for any of these sound effects. So this looks like music randomization. That's pretty interesting. I hadn't come across one of those in the past. And so let's look at one more before we move on. I want to look at the ones in the main game engine. So in this Dracula game engine, this is one that stood out to me. Most of these others are either swaps of memory addresses, or they are just constant values that are switched, so items most likely. But in this case, there's actually a significant amount of code that changes between the two, which is somewhat interesting. Let's see if there's any others that are like that. Here it looks like a significant amount of data has been changed or removed. That is just named differently. That's not an actual change. So let's look at this one here. So here in the original, there's several globals, and those globals are being set based on some index to another global array of objects. So this looks like it's probably setting some default state, and that's done through various parts of the Dracula game engine. Looking again at what that's replaced with. So the original, and that's what we see, is we're loading some offset or some address and then offsets into that address. And then what we see instead here is we're just returning immediately. There's nothing that's being done. There is a register that's being overloaded or overwritten, but likely that doesn't do anything, being that it's an argument register. So that's somewhat interesting. This function was effectively removed from the game, and I haven't gone back to see what these values are. We could go in and look at what those values are. Oh, it could be that my, let me look at the retail that I extracted a while ago. I don't see where this data is defined. Let's look at one more time. No, so that must be part of a different block of memory that Splat extracted. data specifically. And it could be that the name and the memory address are have diverged as well. Yeah, that's really odd. I'm not sure what's going on there. We can look for this variable, though, in the rest of the decompiled code. So it looks like these are animation frames that are being set up. Unsure what their use is, but so those, in this case, are not being set. And that may be for performance reasons. That may be something else that I have not uncovered quite yet. All right, so let's get back to decompiling. Let me find my window here. So yesterday we were working on one of the last functions in the weapon module, and I think we're going to continue on with that for a little while still. We had been looking at both the PSP version and the PlayStation 1 version, and it looked like the PSP version was being a little bit more helpful to get closer to a match. We're at about 84% on the PlayStation version and closer to 90% on the PSP version. And so what I think we'll do is get as close as we can to 100% on the PSP version, and then backport that to, get as close to 100% on the PSP version, and then backport to the PlayStation 1 version. There's already one difference between the two regarding how colors are set up for the primitives that are being built. So this is part of the Werebane sword. And so it has this animation and basically a fuchsia streak that fades into blue. And it looks like that may be what we're doing as part of this code. So kind of going from top to bottom, if you're not familiar with decomp.me, it's a collaborative decompilation tool that allows you to write code, have it compiled using the SDK that was contemporary with whatever game that you're trying to decompile. And then you're able to upload assembly that came from the original game and compare it to the assembly that your code is generating over here on the right. So the target is what we're aiming for, and current is what we currently have with the code as written. And then at the top there's this little meter that shows how close you're getting. It's a relatively coarse indicator, and so I don't... I'll look at that as I'm looking at instruction parity or what the general structure of the code is, but not until we get closer do I really kind of focus on what that number is. So what I'm going to do to get back into this is just kind of scan through the target and current, and looking at this column, of course the stream is not showing the right window. Sometimes OBS does this to me where it will stop tracking a window and I have to reset it. Anyway, so we're looking at this column here, which will give us an indicator. If the lines are matching, there'll be nothing in this column. S means there's difference in a stack offset. I means there's an immediate difference. In this case, the stack pointer is set hex 40 or 64 bytes from the previous stack position, whereas in our function we're only 38 bytes from the original stack position, which is ultimately what causes this relatively large difference between the two. And so we'll see either this stack or register issues throughout until we get figure out what is causing the difference between these stacks. And then so we'll see I as an immediate value. In this case, when we extract the code, we map certain symbols to names that we'll recognize, but those names aren't necessarily how the code was written, and so we'll have some differences there, and that's okay. We know that those differences will lead us to a correct solution when we pull it back over. All right, so I'm looking for the first non-immediate difference, and so I see this register difference at line 70. Biz Murphy yesterday, maybe it was 2 days ago, pointed out that typically registers are reused for the same thing. PlayStation version of the game, or PSP version of the game, is compiled using a MetroWorks compiler. For the weapons specifically, this is unoptimized code, so we get a very linear progression that matches the C code relatively closely. And one of the other nice features is that variables between or that are stored in certain registers tend to stick with those registers throughout the function. So I'm looking on line 70 here to see what might be the cause here, and I see that there is this load of a immediate value of 22 into register S5, whereas in the original it was being loaded into A1. A1 is often used as an argument register, but if it doesn't need to be used for an argument to a function, it'll just be used for anything. This is happening again on line 80 here. And so what I would expect to see is, assuming our code is correct, we'll continue to have these same values appearing next to each other. And so here's our first divergence, where we still have value S5 being used, but T1 is being used in the original. So at some point, these values have split, and we need to figure out what's going on and how to get them back into alignment. So in this case, I'm going to try to change this to a plus equals to avoid potentially a load. Occasionally I'll look at the decompiled version as well to see what might be going on. In this case, the issue is that we're loading the Y value from player followed by the X value in the original, and then checking draw flags, and finally then doing any addition with those values. So it looks like we're missing some temporary variables that look like they're needed. So I'm going to add some, and hopefully that'll be enough to straighten this out. Well, it's odd to see Y coming before X in this assignment. It's not it's not completely unheard of either. And so I'm going to go through. There definitely is an addition that's missing, but I'm going to see what how this may have ended up. So I'm not using this X offset and Y offset yet. So I'm going to introduce some lines that do use those. All right, so this is actually looking much better already. Looking at these registers above that were misallocated up here, those actually have straightened out now, and I didn't have to do anything to this particular line. That's one of the things that can be frustrating about decompilation is often the compiler will do things that you don't necessarily think should happen, or results from the compiler don't seem obvious to what their cause was. So there is a difference here. I'm not too worried about it yet. So this is saying that these are branching to different places, and that is true. But this is the additional line. This line is actually supposed to be down here much further, and so we'll put that down here. And that should get us a little closer. So I'm trying to kind of carefully introduce this minus 14 without without affecting too much of the other code around it. So let's look back here. So A0 was our Y position, and then S7 is this minus this 14 value. I'm going to reorder those, even though the loads are in the wrong order. It's possible that these are happening in the right, that they've been flipped. MetroWorks doesn't often do that, but it could happen. And so I'm going to so these adds are happening not necessarily in the order that I'm expecting. It does look like the X this X offset is happening prior. which helps. We still have some register issues here. So in our case, the load is happening in the correct order. As well as draw flags. So even in the MetroWorks compiler, when it's not optimized, it will still reorder these instructions pretty aggressively. So that's a bit closer, but still not quite right. I'm just kind of playing around with how these are written. To see if any of these are going to end up matching better. And I don't see... ultimately, what we want, however, is right now for this this V1 and S5 at the moment, we want these values to be as or the registers to be used in the same places. And so already there's some divergence down here where V1 is being stored off into the stack and being used for something else. So we have to track this stack value at this point and see if we're being used in the same place. And it does look like it is. So I'm going to stick with this. And I might actually go and just check some of the other weapon functions. Grabbing the player position and then changing the offset based on the direction of players facing is a relatively common operation within the weapons. So there's almost certainly some code we can find that does this same thing. So off screen, I'm just gonna do a quick search for similar functions and weapons. So weapon 38 actually looks like it's a good example. I'll open that here. And this likely is very similar, because close weapons are often coded in a similar way. So this one is the rapier. We can look at that as well. Mostly I want to see what the animation looks like between the two. And this actually, so the animation itself looks extremely similar to the werebane. It has the same like checkmark, sideways checkmark pattern. This one being green instead of the other, which is obviously fuchsia to blue. And so we're going to steal this this implementation. I mean, it's so similar that even the offset values are the same. So this particular draw flags is going to be a draw rotation flag. And let's go back starting at line 81. We can just walk kind of right through this now. And except for registers, this looks correct now. This value is going to be wrong, and now that's correct as well. So we still have register issues, but the instructions are matching, and so we can deal with the registers later. Interestingly, this appears to follow basically the same structure all around. I'm not seeing anything obviously different here. The first difference actually comes down here. I may rename some of these variables to match because these functions are so close. But let's kind of scroll past this section. So there's some issues here with how these arrays are being set, and in the original these are being pulled out almost as pointers. I'm not sure about the details of the PSP compiler. So in this case, this address is being loaded and stored in S4. And a separate value of 0 is being stored into S5. And so we need to determine whether or not it looks like S5 might be being used as the I value in the original. But it is a separate variable that's tracked differently. So let's see. So it's being used down here. Biz Murphy made a comment about the at variables the other day, and I don't recall what he said. So the things that I am noticing, though, between the two, there's several constants that are getting pulled up into shared variables where they're not in the original. And things like this, where this value was put on the stack earlier, but it's not in ours. So there's some things to figure out. I actually see one thing that may seem minor as a developer reading this code, but actually often in MetroWorks is kind of a big deal. So in this case, this prime R3 value is being incremented by 1, and we'll find that down here. This, interestingly, isn't even being given a an instruction. It's getting pulled into something else here. So its line number doesn't show up here. I'm going to change this, though, to the increment operator. And we see a pretty big shift in the code that was generated for something that, as a developer, we think of as the same thing. And that's, in this case, that's completely because of how MetroWorks treats this in a non-optimized code path. Okay, so this we have these loads that appear to be happening out of order. So let's try to get those back into order. I'm going to take them out for now. So in the original, Y1 is this offset 16. This is happening earlier, but we're storing the value and then we're loading it back again. And so when this value is being loaded back again, oh, this is where it was being stored then into this other array. And so then we see the same thing with this x value. It's being stored as well. And so what ends up happening is we have okay, so it looks like it's not just being stored, but potentially being added and then stored back at this location. And so this is S5, which I called out earlier, and now doesn't seem to be used in the same way. I think ours, oh, it's this this S5 here. So we're doing something to add this value at offset in this particular array. And I just want to scroll down quickly to see if this is something different than I and how this S5 is being used later on. Okay, so it's being used to, it looks like it's being used to set a pointer. So this is a different structure than what is present here. Oh, somehow I got over to the PlayStation version. drat and double drat. How long have I been working in the PlayStation version? I don't remember. Let's... Yeah, so I need to back up a ways. I wondered why we had regressed. So we need to fix this this code path in the PlayStation version, or the PSP version. That's what happens when you have too many tabs open and you're flipping between too much stuff. And let's confirm that again, that is what that change was. So here, again, I'm not too concerned about registers. I'm mostly just concerned about the instructions. So this is wrong, but then the rest of it falls into place. So all the instructions are correct. We just have registers that are mismatched at the moment. So I'm not too concerned about that. All right, let's keep going down. I'll look at cases like this on 105. So in the original, 16 is being subtracted, and ours has, 28. So we can fix that and get that to match. And then the same thing here. It looks like 16 was, nope, that's the next, oh no, that was correct. And so we just need to go through and fix all these as well. So on line 112 here, the offset by 2 is because of the type that I've given this this array. And it looks like that may be the purpose of this other variable that it is I being used. So these two arrays, and I'll go back to the original as well, these two arrays are far enough apart that they appear to be different. And I think when I was looking at this originally, I had convinced myself that these were part of the same array, but that doesn't look to be the case anymore. So I will find the original values for those. So this is one of those cases where the offset does matter. And so looking at these, it's this A2C array versus this A6A array. So I'll pull those out. So this would need to be an 8-bit value then, if our offset is only being multiplied by 1. So this is going to break some things because I'm changing these types now. But I think this will end up being a more correct change. So we're down here on line 113. And so we have a few other errors that need to be resolved because of that. Basically, any time these are grabbing X or Y needs to be fixed, and it's likely that these addresses are now wrong as well. So we'll just have to make sure that we keep track of that and fix that. So that caused other issues, and those issues are because of the type changes. I'm not too concerned. It looks like a reasonably large regression, but I'm not concerned about that yet. It may be an issue, but we'll see. So this was a 16-bit value, and that should help changing this back to a 16-bit. I took the shift left by 2, which is the same as a multiply by 4. I was thinking multiply by 2, which is why I made that mistake. So then this falls into place, and it's just an immediate value change as well. And all the other offsets, so this prime x1 and y1, those work out, and those are correct. And we already see that we're pretty much back where we were earlier. And let's see if any of these other registers, the other registers haven't fallen into place yet. That's fine. So I want to make sure that S4 and S5 are the same thing. So I'm going to kind of go back and do the same thing, just make sure that they're positionally correct. And as long as they're in the same position and there's nothing obvious here that indicates that they are different values, I'm fine with that. I do see an instruction that is in the original that isn't present in ours all the way up on line 57, and I might... I don't think that that is worth looking at yet. It's moving the value of V0 into V1. I don't think that has anything to do with the code up there, and it'll fall into place. So kind of going back down, we want to keep going on line 117. Actually, we can pull this back over as well into the PlayStation version now that we're a little more confident. I'm a little more confident, and that does get us a closer match on the PlayStation version as well. So line 121 is where we first see an issue. This is common on the PSP version as well, and there's a couple of these. When kind of like the increment operator, which is here, which is an issue. This won't be an issue in GCC, but it will be an issue in MetroWorks when optimizations are removed. This changes the code significantly enough that we'll get one thing out of there. And of course, this one actually does not change anything, but this one will. This is when we're looking at the player facing left, we don't want to explicitly check it against the 0 value, which has a specific meaning in how many bits need to be checked. We want to use this form where we're just saying whether it's set or not, whether it's a non-zero value or not. And then the compiler, even with no optimizations, will generate slightly more efficient instructions there. So here we see a sign extension for S2, and we didn't see that above. A sign extension means it wants to do a 32-bit operation, but it only has a 16-bit value. And those are signed values, so it can't just pad out zeros. It needs to understand whether the sign bit is set and then extend that to make a matching number. So S2, we are, let's see, make sure I'm in the right place, line 122. S2 is being used up here, and XPOS is a 16-bit, and so is the value that it's being assigned to, so I'm not sure why the compiler thinks the sign extension is necessary. There is it looks like this store into BC8 is happening up here in this case. And so it may be just this direct store into this value, but no, it doesn't look like that. So if we're not facing left, there's a bunch of, we're doing the subtraction. Let's see if we can change that to just a decrement. It still wants the sign extension. And then we will set this value. So that's nearly correct. And then we can try setting this here as well. So in our in the original, there's more work that's being done, and so we need to make sure that all of that is happening. So in this case, we're adding so we still have a sign extension issue on line 123. It looks like it isn't storing this value, it's loading this value. So this isn't quite right yet. This is better. Let's look at what V1 is here. V1 is facing, the result of facing left at this point. Oh, it's adding S1, sorry. S1 is set on line 117. Sorry, line 118. Oh, so that's the I. We're looking at the previous one, so I minus 1. Okay, then that's where the minus 1 came from. So the rest of this can go away. In this case, we're going to need something similar. And likely this is just the inverse. So not quite. So it looks like, yeah, it swapped those around. This is unnecessary now. Maybe it's more necessary than I expected. Alright, so we're going to be doing something similar. Oh, so this is grabbing the y value now. So this first one goes away. This is going to be I-1, but we have the wrong array. We need this array for the y values. We'll still see these immediate value differences, and there's nothing we can do about that at the moment. We're wrong on our offsets here. Very wrong. So this is for our primitive, what is that offset 18. And so let me look up that structure. That structure is in a primitive.h file. We are looking at the PSP version, so we have to subtract everything by 4. So that is x1. Oh, but C, however, is y0. So this may actually be flipped. There may be more work to be done here that oh no, what am I doing? 18. Sorry, I was looking at C over here. So I'm doing C, which is x0. And I need 18, which is going to be x1. In this case, these conditions are identical. Oh, we're adding versus subtracting. Got it. So they are identical. All right, so now going down, 128. This needs to be fixed to the right array. Moving down a bit, these need to be fixed as well. So that I'm pretty confident with, and these other ones are going to fall out, and they're going to largely be the same. All of these conditions are relatively, oops, not that, are relatively similar. It's just getting that cracking one, and then the others fall into place. On line 136, there's a move that's not being done. Again, I'm not going to worry about that until we figure out the rest. So the same issue with facing left. So we're gonna do a not facing left. Down here we're gonna do an increment instead of plus equals. And then my guess is that it's some of these constants that need to be fixed. So we have a difference in where this branch goes, but these offsets are due to other errors above. So every time I'm using x, I want to make sure that this is going to the right value. That's going to not be necessary anymore. This y0, we're going to reorder that and make sure that it's going to the y array, which it looks like it is, and then make sure that these are going to their respective arrays. And so we're getting register differences here. There is an immediate value on line 140. So there's only register differences here. I'm not concerned with that at the moment. So the first difference, though, we see is that there's a missing store for offset 1A. 1A is going to be U1. So we have our store at offset 18, which is X1. And we're setting that to the value of S3. Which is also being used on line 137, which is the Y position. My guess is that this is... I have the offsets wrong. U and V are offsets within the... Yeah, I have my offsets off. So I'm doing 1C. We'll figure this out. I have my... I'm missing a... I'm not setting Y1. There we go. So now this is shaping up pretty well. So there's still some moves and other things that are not present. So it's not perfect and it wouldn't match yet on PSP. But I do want to take this back over to the PlayStation version and see if we have a match there. So we're at 97%, so that's really good. Let's see what issues we have over on the PlayStation 1. most of this has fallen away now. Immediate values, not concerned with those. So here we have an address that looks like it's wrong. So I have an offset of 2 for this where the original does not, so that's up on line 95. This is, okay, so this happens occasionally. We may want to be looking at offset A68 instead of A6A. And when this gets compiled in GCC, like in the project, that may illustrate which one is the correct one. This is kind of similar. Here we're using A6C versus A6A. That's probably the same thing. So this difference actually is a bigger deal. This code, which was all necessary on the PSP version, is completely missing from the PlayStation version. So these last 2 lines need to go away, specifically for the PlayStation version. And potentially this draw mode as well. So that after that, that leaves really just one more issue here. We're jumping to the wrong location. But other than that, something very similar. And that's because this, why didn't this get pulled over? This is on the PlayStation version, but because of optimizations, and this deviating slightly from the other, all of these last several lines, or at least these last 3, need to be identical. And here we're doing a plus equals versus a plus plus, and that seems to be enough to throw off the compiler to not optimize those out. Yeah, there's some array differences still. I need to correct the addresses on those. But other than that, we have a match, which is awesome. So this is, I'll clean this up offline and send a PR out for this. And so when we come back on Monday, we'll be at 7 functions remaining or less in the weapon 0 file. Super exciting. I estimated, I think, last week that this was going to take another 10 days or so to get rid of the rest of them. Due to some participation and other things on the project, it's been going a little slower this past week. But we're still plugging along, and I think there were maybe 15 or so. I don't remember the number from last Thursday. But we're down quite a bit from where we were a week ago, and we'll continue plugging along and hopefully get the rest of these knocked out. It still might be another 2 weeks, but that's how software goes, right? You never know exactly what's going to happen. So the only change that I made between the PSP version and the PlayStation 1 version is fixing this this increment here, and surprisingly, it didn't do much over here. I'm gonna pull all this in, and yeah, so there's still something with the PSP version that needs to be resolved. It looks like towards the top here. Oh, this happens from time to time as well. Let me see if weapon 38 has this. So here, I might as well fix this while we're together. I actually fixed this, or solve this on the weapon 38 as well. So here we have params, and we're pulling out params. Still not perfect, but there's a bunch of code here for extracting assigned 8-bit value from params, but that params is never used. The rest of it actually straightened up quite a bit. Let's see if these match. Yeah, these are the same. So there's still two. It looks like I have two variables that are no longer needed. It may be these, and we could try that. I no longer need xpos and xoffset once they're used here. And so this might be enough to... There we go. There. Nice. The PSP translation ends up being very literal. So we have a match on PSP as well. Like I said, we still have not a perfect match. Nothing's ever perfect, does it? Nothing ever works out quite like you want. Nearly perfect match on PSP. There's still some addresses that need to be fixed. But that should be a fairly straightforward thing. So that's awesome. I'm glad that we got to a match there as well. So offline, I'll fix those up and get those checked in. So we've been working on converting MIPS assembly back into C from Castlevania Symphony of the Night. If you want to know more about decompiling Castlevania Symphony of the Night, you can go to SOTN.z.dev. You'll see progress on several of the files that we're currently working on. And on this stream lately, we've been trying to finish off the remaining weapons. There should be, there was 8 as of this stream, and hopefully tonight there will be 7 remaining functions. If the PSP version keeps making these as easy as it has, I'm pretty hopeful that they should be done by next week sometime. There's still several other files that are being matched, stages and other things like that, and then there's a host of other things. The Alucard program, for example, hasn't been started. The Maria program from PSP hasn't been started. So we're not close to being done decompiling Castlevania Symphony of the Night, but we are getting closer. So if you want to keep following along and see what the progress is, come back on Monday. I may be shifting the time, either an hour earlier, maybe keeping it the same, we'll see. Go to SOTN.z.dev, join us on Discord, and if you want to contribute, it's a super friendly community, and they or myself will help you on board and get going. So thanks for watching. Bye.